Hi friends, what is going on? In the previous video, which is video 5 in this playlist, we introduced Java programming language. And under the high level language translation, we learned the traditional compilation process and many more. So in this video, which is video 6, we shall continue from where we stopped. We'll learn the Java compilation process and we'll have an idea how a Java program looks like. In the previous video, when we were talking about traditional compilation process, we saw that the traditional source code gets compiled directly to the object code, which is understandable only by the platform it is compiled in. So with Java compilation process, it is different. The Java source code, which is saved with the extension .java, gets compiled to what we call the bytecode, which is saved with the extension .class. This bytecode too is a binary representation of our Java source code, which is also zeros and ones, only that it is not as restrictive as the object code we saw in traditional compilation process. So this bytecode, which holds a bunch of zeros and ones, is understood by all platforms that have JVM, which is Java Virtual Machine. So this is the JVM and it means the Java Virtual Machine. What it does is simply interpret these bytecodes to the native language of the platform it finds itself in. That is just it at this level. It just sucks in the bytecodes and then translates them to the native language of whichever platform it finds itself in. So with this technique, Java can be run anywhere, because regardless of the platform, when you compile a Java source code, it produces bytecode, and these bytecodes are understood by the JVM, and JVM has the ability to translate this bytecode to the native language of the platform it finds itself in. So Wintel as a platform has its own version of JVM, PowerMac as a platform has its own version of the JVM, and so on. All platforms have their own version of JVM. So now let's look closer at this diagram. We have our three Java source codes, a1.java, a2.java, and a3.java. Each of these source codes gets compiled individually into a bytecode. A.java gets compiled to a1.class, a2.java gets compiled to a2.class, and a3.java gets compiled to a3.class. So at this level, we are done with compilation. The class loader sucks in any .class file, which are the bytecodes, into the JVM. Once it sucks it in completely, it then passes it to the JIT compiler. Don't be fooled by the name. It is technically an interpreter. We call it just in time because it works just in time of execution. What it does is that it picks these bytecodes one instruction at a time, translates it to the machine language of this platform, then pass it to the execution engine for execution. So you can see at this level, interpretation takes place. So with this, we can conveniently say that Java programs get compiled first and then get interpreted. And this is simply how Java achieves its platform independency. Because now I can compile my Java source codes in my Windows computer and then give you the class files, which are the bytecodes. Once you take them to your Mac computer or your Linux computer, you would perfectly execute them if you have the Java virtual machine. So a good question to ask here is that when we were dealing with traditional compilation process, we assume having three different source codes that are dependent on each other. And then we saw how those dependent source codes are compiled to .obj files and then linked together to produce an exe file, which is the executable file. But here we can clearly see that the linking mechanism is missing. But that doesn't mean linking doesn't occur. We can't see the linking mechanism because it is done inside the JVM. So here we can still assume that these three source codes are dependent. So once they get compiled to these .class files, which are the bytecode, they still remain dependent. It is the work of the class loader this time around, after sucking them in, to link them together. After linking them together, then passing them to the JIT compiler, which is the just-in-time compiler, to translate them just in time and pass them to the execution engine. This is simply what we call the platform independency of Java programming language. Now that we know a brief history of Java, its features, and how it is compiled, let's look at the structure of a simple Java program. We always wrap our entire Java program in a container called the class. So this is it, public class, then we give it a name, then we open a curly bracket here and close it right here at the end. So this defines the container where our codes will fall in, and it is the class. Also, inside of this class we have the main method, which is also a container that wraps our instructions or our statements. And this is the syntax for this main method. It starts with the keyword public, static, void, main. The main here is the name of the method. Then in a bracket we have a string array, which we'll cover later in this course, and then the open curly bracket and its corresponding closing right here. Note that this main method is also called the runtime system because that is where execution starts. So now when you run your Java program, the codes that are inside your main method are the ones that will be executed first. Inside the main method we have the statements, which are basically any form of instructions we want the computer to execute. A statement can be as simple as 1 plus 1, which is an instruction to add two numbers. It can also be an instruction to print out something on the screen, and so on. Statements are terminated by semicolons, so that's why after every statement here we have a terminating semicolon. There is no limit as to number of instructions we can have in a program, and that's why here we have from statement 1 down to statement infinity. Also note that words like public, class, static, void, main, string, and args are called keywords or reserved words. They are words reserved by Java creators and they have their individual functions. Another important thing to note is that Java is case sensitive, which means each and every word that you see here must be typed as such. Bear in mind that this is just a sample, so when we start dealing with real programs, the class name here will be substituted by a real class name, and also these statements will be substituted by real statements depending on the kind of instructions we want to give the computer. Pay attention to the fact that this structure remains the same. This is the class definition and this is its corresponding closing, and this is the main method definition with its corresponding closing. Inside our main method we have one statement. So we have our public, we have our class, we have our static, we have our void, we have our main, our string, and our args. All these are spelled as they were spelled in the previous example. And we have hello, which is our class name. So public class hello. Also pay attention to the naming convention of this class, that the first letter in every word of class name should start with a capital letter. This is also called the Pascal case notation. Inside our class is our main method, which holds our single statement, and this statement is system.out.println with some strings surrounded with double quote inside a parenthesis, and most importantly at the end we have our semicolon to terminate the statement. So if you have a computer that is up and running for Java and you write something exactly like this, you would have it on the screen hello world when you run the program. In the next video, we will see how to get our computers up and running for Java. That is all for this video. See you in the very next one.